Hi, it's 6 p.m. and we would like to start the section for the day. Good evening, everyone. Welcome back once again to African Women in GIS, 7 days masterclass in GIS for beginners. If you are here with us and you are hearing me, can you kindly indicate on the chat box so that we can proceed? Yes, we can see you, Erica Benz. Welcome. If you are here, so that we can dive right into the business of the day. Good evening, Ellen. Good evening. Good evening. Okay. Thank you very much for indicating. Welcome back to day 3 of African Women in GIS training. Today is the 3rd day of this training, and we really appreciate our viewers and the participants for your patience and for following us through from day 1 to day 3. So welcome once again. Today is day 3, like I said, and our facilitator is Oluwadamilola Salau. She's a geospatial analyst at OEA Consult and also a member of African Women in GIS. So she's going to be taking us through today on georeferencing and creating map. So before we start, I don't know if anybody has any question or any concern, or if you would prefer to practice with us while we forge ahead for the business of the day. Can you kindly indicate? And also, if you have challenges to download the QGIS, we have also sent you links to download the QGIS. So we sent out a reminder today about the training we had yesterday, and the manual for yesterday's training, the data set for yesterday's training, and also today in advance, due to the requests we are getting from our participants, we have sent out a list of the manual and the data set that will be used for today's training. So please down with the training so that you will not be left behind. Just to quickly remind us that the training is for 7 days, and we are already in day 3. If you can see the agenda on the screen, the agenda, we're already done with introduction to GIS, data types, familiarizing with the software, which was yesterday. So today is georeferencing, digitizing, and map creation. So a quick recap about yesterday was the QGIS interface, and some questions were answered yesterday. But if you think you still have some things you would want us to clarify, please kindly drop a message on the chat box and we would answer you. So without wasting much of our time, we have our speaker here, our speaker, Oluwadamilola. I would like to introduce her once again. Oluwadamilola is going to take us to digitizing, creating map, and georeferencing. Oluwadamilola, are you here? Okay, while we wait for her to set up, if you look at my screen right here, you will see this is just a screenshot of the QGIS interface, which we covered yesterday. We know we might not be able to cover as much as we are planning to, but we will try to cover out some of the most important parts of the training, which we feel will be relevant because we are looking at the basics and people who are beginners in GIS. So looking at the interface, we can see that there is a tab two tabs for browser, one for layer on the left-hand side of the view. And also someone had a query about how to import CSV file. So you can see we've drawn some arrow to show the boxes and what they do. So on the processing tab, when you click on the processing tab, it brings out the panel on the left side. And from the panel, you can see series of processing tools you can be able to use for various processing. Sorry, Oluwadamilola, are you here? Okay, sorry, we are still waiting for her. I'll quickly go over to the comment section to see if we have questions we can answer. Okay, someone said, I have a question. How can I unmute? Sorry, because of the number of participants we have for this training, we are unable to carry out the training using Zoom or Microsoft, where you'll be able to unmute and talk. But this is YouTube Live, so if you have any question, we know it's going to be training. So please drop your question on the comment section. We can see the comments. We would reply to you as soon as possible. So please, if you have any question, we apologize for you not to be able to unmute to talk to us, but just drop your question at the comment box and we'll be able to answer your questions. So someone said yesterday we were not seeing how the facilitator was clicking and changing to other features. Okay, sorry about that, Emmanuel. That is why we have sent you some of the data sets that were used yesterday as well. And we have also sent in advance to the data set we are going to be using today, and the manual and the steps to follow. Looking at this screen here, if you look at, we have also displayed a list of training manuals. So there is a training manual for QGIS. So if you will be able to follow that training manual, I think it should be able to give you the proper guide in case you have missed out on any section. So there's a training manual link. I would also paste the link on the comment box as well, so that you can check it out yourself. So we really apologize for not following up with the facilitator. So this is basically the interface, and the link I'm going to send on the comment section has all the tutorials you need on the QGIS interface and everything. So someone says, my question is, only women are members or anyone can be a member? Okay, yes, this is African Women in GIS. For you to be a member, it's for women in Africa, irrespective of where in Africa, West Africa, North Africa, East Africa, so it's a platform for women. But the good news is that most of our training and our activities are almost always open for the public, so both women and men. So for this training, it's always going to be available and you'll be able to partake in the training. But for you to be a member to access so many other features or benefits from the African Women in GIS, it's for women alone in Africa. Yes, so sorry, the African Women is for women entirely who are around the world in GIS or who are interested in joining the GIS field. So it's open for all women. So someone said, I'm struggling to get the QGIS software. Yes, please, if you're struggling to get the QGIS software and you registered for this event, we have sent how to download a video tutorial on how to download QGIS, and we have also sent the link for you to download the QGIS on your system. So if you follow the link to download and you experience any challenges, please follow the YouTube tutorial attached on the email. we have sent to rectify the problem. So if you're seeing my screen, you can see a link beneath. I'll also paste it on the comment section, a link on the training manual on my screen. So someone says, hope the trainings are not only meant for women. No, the training is open to everybody who is partaking and who is interested to learn more about GIS anywhere in the world. So it's open, it's free, and it's open to everyone. So, okay, so I can see there are no more questions. We will dive right into the business of the day, which is georeferencing, digitizing, and creating a map. So I would like to welcome our facilitator for the day. Our facilitator is Oluwadamilola. Oluwadamilola, welcome.
Thank you for having me. Okay.
So Oluwadamilola, over to you.
Okay, I'm trying to set up my workspace.
Okay, that's fine.
Okay, hi guys. So my name is Oluwadamilola, and I'll be taking you guys georeferencing, digitizing, and map creation. So we are just going to jump into it really fast so that we can have time for the practical aspect of this today's training. So can you guys hear me?
Yes, we can hear you.
Okay, thank you, Nina. Okay, so for every GIS job, at least most GIS job, we usually have 4 major steps. So we have the step of acquiring the data, georeferencing, analyzing, and visualizing. So I'm sure Wonola did justice to the part of acquiring data, the data sources, the types of data that we have, and where to get the data from. So that is covered. So the second aspect of the second step is the georeference. So what is georeferencing? So georeferencing is just the process of attaching coordinates to a place or any location on the surface of the earth. But the general, maybe one of the definition is georeferencing is the process of transforming a scanned map or area photograph so it appears in space, in place. So it's more or less like making sure your scanned document, maybe somebody sent a map to you, or maybe an image, maybe a satellite image, and obviously it's probably, except if it comes in maybe like in cases where it comes in a JPEG file format, then PNG, then even TIFF. So you might need to have to, if it's not your reference, especially when it's a raster data, you might have to go through the whole process of georeferencing that data, so that by the time you're overlaying it or even analyzing, you won't end up with a data that has locational error. That is the major purpose of georeferencing. It is just to assign real world coordinate, that is latitude and longitude, to images or scanned maps. So let me show you guys a copy of what a scanned map looks like. So something like this. So this is a scanned map. Then we also have image like this that is in JPEG. Then we can have it in PNG too. So the main purpose of georeferencing is just to assign real world coordinates, that's longitude and latitude, to imageries or scan documents that don't have locational attributes. That is why we need to georeference our data. So when we talk about georeferencing, we cannot take away georeferencing from CRS. And CRS is just Coordinate Reference System, CRS. So CRS is a coordinate-based local, regional, global system used to locate geographical entities. And the CRS is like the source. Okay, what is in the okay, your data after georeferencing? Where are you georeferencing? What particular system are you georeferencing with? Is it and there are two major types of general CRS. So the first one is the projected coordinate reference system, which is the PCS, and the geographic reference systems, that's the GCS. So most people ask questions like, okay, what are the differences between the PCS and the GCS? And in my own way, the way I like to explain it is more like, okay, the GCS is like the world, it's like the Earth surface itself. It's depicting what the Earth looks like. So it is round. It looks at the Earth in this kind of round, spherical surface that we're looking at. So, but the PCS more like looks at it like a flat surface, more like depicting the map on a flat surface. That is, I like to talk about GCS and PCS, but you might meet someone that wants to go into the technical part of what coordinate system is all about, where they start mentioning things like map projection. And if a surveyor should break down this map projection for you, you'll be wondering, even high that a professional in like a GIS analyst, I would just look at the person like, okay, can you break it down more? And you can just look at things from a different way, where they explain how the spherical Earth is divided. It's just depicted on a flat surface. That is, they will explain, they'll go into a major discussion about that. But for today's training, we won't dive much into map projection. But you can read about this, and maybe just to understand the background of what map projection and coordinate reference system is all about. So we have two general CRS, and that is the GCS and the PCS. So this is something I got from Esrael, a blog on Esrael, and they were trying to differentiate between the GCS and the PCS. They stated how GCS define where the data is located on the Earth surface. Then the PCS tells you exactly how the data will be drawn on a flat surface. But the most popular GCS, that's the geographic coordinate system, is the World Global System, which is the WGS 84. While the most popular projected coordinate system is the Universal Transverse Mercator, that's UTM. And in Nigeria, we have 3 UTM zones. So we have zone 31, which is usually let's say most of West Africa, like Lagos, then zone 32 like Abuja, then zone 33, anything from the east and far south. Okay, now you can read more about this, but one thing you guys just need to understand is there are two major types of coordinates reference system. So now that we've covered that aspect, we want to look at the methods of georeferencing. So if you meet a GIS person today, they might tell you that the way I georeference my map or my image is different from the way Nina georeference data. Then Wonola can tell you that, okay, I don't georeference my data like you guys, but have another step, have another method to do it. So we'll be looking at three major methods. The first one is using grids. That's like the horizontal and vertical lines drawn on the map to show something like maybe distance, location, and all. So these grids are usually on a designed map. And if you even check Google Earth and all, if you look at the grids, you can see those grids. I can't design a map without putting grids. This is more for future purposes where I might be sending this map. It might be a finished product and I'm sending you an image. But what if later in the future you want to work on the map and they are looking for a way to convert from just a normal picture, which is a JPEG, to something you can work on in the GIS environment. So it is best that when you are creating your map, that after the whole analysis, you're referencing at all, make sure you are putting your grid lines. You can make it faint so that it does not really look so obvious on your map on off, but it makes it easy for someone else to reference this data in the future or something. Because like the scanned image I showed you guys, that's an image of, let's say, I think it's India. Yes, India, and this is like 1870. This is a map done 1870. So imagine now if they didn't have this grid, these are the grid lines. You can see this vertical and horizontal lines. If the person that designed this map didn't had this grid, georeferencing this data might take a long process. But because there is a grid there, it's easy for me to say, okay, I can use this grid to georeference this map and make sure it has real life coordinates and it's placed on the Earth surface. Like by the time I'm putting in by the time I'm georeferencing this and generating or even including a coordinate system like the geographic coordinate system, I can use the WGS 84 and say, okay, this is a map and this is the exact location following the horizontal and the vertical lines, which are the grids. So the second method of georeferencing is using the pinned latitude and longitude of images. This is my favorite method though, guys. So every time I download an image from Google Earth Pro or Google Earth, I make sure that immediately I get my ROI, which is my area of interest, and I want to say, okay, I'd already gotten the extent that I want to the extent of my ROI. I make sure that I put all these kind of placeholders to show I just pick a point on that map, that my ROI, that's the area of interest. Pick a point and make sure that I write the latitude and longitude just to label that placeholder that I'm placing, and do that for at least a minimum of 4 points. That's what I like to do. It saves me the stress of looking for grids. Okay, what if there's a case that you're the one downloading the image by yourself, you're not getting a scanned document from anybody or anything. So this is, if you're downloading the image by yourself, it is best that you have make use of the placeholder and just make sure that you label the placeholder according to the latitude and longitude of wherever you place your tags, like placeholders. So let me show you an example of that. Let's see. Okay. So can you guys see? So this is an image I downloaded this afternoon. I make sure, so these yellow stuffs are the placeholder, and as you can see on the map, you can see the longitude and the latitude. But here, the reason why you are seeing, most people might ask that why do we have latitude 72090.77 or latitude 71288 north? This particular data is actually all about northings and eastings. This is UTM. But if you look at another one, I have another image here showing let me check. So this is another image, the same area, but look at the longitude and latitude. This is in decimal degree world global system. That's the WGS 84. This is what the latitude and longitude looks like. It's different, as you can see, it's different from the first one I showed you, which that the latitude and longitude are actually in eastings and northings. So you might have to convert, maybe using an online UTM to latitude and longitude converter, like this one, majorly this one. Can you see convert from UTM, that's Universal Transverse Mercator, to coordinates, that's longitude and latitude. So you can convert this online. If where you are downloading from just have northings and eastings, you don't need to worry about it. Just convert from UTM to your normal latitude and longitude degrees. Okay, so that's my favorite method for georeferencing. So the third method is using a georeference data to georeference your scanned or your image that does not have any coordinates. You can do this like maybe getting a vector data, like maybe the road network of that particular place, or maybe the boundary of the place. Then use that, since it's georeference, to georeference your scanned document. So I'm going to show you guys these three methods. So you can, so by the time I show you guys this method, you won't have a situation whereby maybe there's grid, you'll be able to georeference, even if it's just grid, you'll be able to georeference even if it's just placeholders, and you'll be able to georeference if your scan data does not have any coordinates. So let's just start the practical section. So can you guys still hear me though? Oh,
Yes, we can hear you.
okay. So this is my QGIS interface. Sorry for the the way my interface is loaded. This is just I've been using this particular version for a while. So I'm sure Oluwadamilola did justice to showing you guys what is what on this surface. So just going to bring in our data, but if you are georeferencing, the first thing you need to do is go to your raster. I'm doing the first method, which is using the grids on a map to georeference the scanned map. So you just go to your raster. From your raster, there is, well, one of the options is georeferencer. So you just click on that. So to bring another interface like this. So from here, you have to bring in your data from file. Just say open raster. Then go straight to try and locate the map, the folder where you kept all your data sets. So for me, I'm sure they shared this particular data set, which is this data set D3. So I'm going to pick this Nigeria. Then click open. So okay, so now we have to pick your points. So we have to zoom in. If I zoom in very well, you guys can see the whole the way the grids are. Okay. think this is too much. So can you guys see the blue lines? Not this one, not this one that looks like a river. This 4 degrees and 12 degrees. So these are the grids. We look at it very well. So you can see the grids. Make sure you label your grids too when you are designing your map. If you don't label it, I wouldn't know, okay, which one, okay, what degree is this one, okay, what degree is that one. But if you label it like this one is labeled, I can see, okay, this is 12 degrees. Then if I move it, I can see this is 4 degrees, 8 degrees, then 12 degrees, then just like that. So now that we have our map in the georeferencer the interface, now we can now pick our points. But for one thing I need you guys to understand, in when picking points, let me show you guys. You have to just this particular icon, this add point icon, just click on it, then drag it to the middle. Make sure you zoom in very well to the middle. This is too much, just zoom in. Yeah, so and then click on your add, but then just pick the middle where this the horizontal and the vertical line intersect, like this. I think I made a mistake. Okay. Okay. So if this particular thing pops up, this enter map coordinates. So there's a catch. So once you do this and it pops up, this east and north, x and y. Your x is your 4 degree and your y is your 12 degree. Do you guys, can you guys see it? So your 4 degrees is the x, which is the east, then your 12 degrees the north. You would wonder why, because in a typical map graph, you would notice that, okay, the horizontal line is usually x and the vertical line is usually y, while the horizontal line is usually x. But in a map situation, the vertical line is usually the x, while the horizontal line is usually the y. So that's why that's a major issue where people, when they want to georeference, they make this mistake thinking it's the normal math x and y. But for map georeferencing, it is the other way around. So just think of it as your normal x in a math graph is not x, is y, while the other one that is supposed to be y is x. So for this one, so our longitude, which is the line, is the x is 4, while the latitude here, as you can see, is 12. Then you click OK. Then you pick another point again. Maybe like this point. I zoomed in too much. Okay, this Jajeri or something. Just pick that position, that intersection of the horizontal and the vertical line. But be careful so that you don't pick a wrong place. Okay, so for this one, you can see that the longitude is 12 and the latitude is 12 too, following the lines. So we have 12. Okay, then we can pick another one. I usually pick a minimum of 4. So just to avoid any kind of issue, so you just pick a minimum of 4. So for here, that you can just pick here again. Then just then you zoom out to check the coordinates. So we have 12 and 4. So this is 12, this is 4. Click OK. Then the last one, this side. Let's pick the last one. So we zoom out to check the value of the longitude and the latitude. So we have 4, 4, and 4. So longitude 4 degrees and latitude 4 degrees. So we click OK. So now we have 4 points, which I feel is okay, but you can add more points, maybe like pick this part, pick this part, or pick this part. It's never too much. So once you are done with the picking of the points, you can now click on this transformation setting. This setting icon, this transformation setting here. Then this pops up. Then you have to decide on the transformation type you want. There's Lilian, there's Hellman, there's polynomial, 1, 2, 3. There's projective, there's thin plate spline. And I prefer to use the thin plate spline because the mean error is always, I've tried it a couple of times and I feel like the mean error here, as you can see, let me show you guys. The mean error, that is the average error after from the georeferencing, is usually small when compared to maybe the polynomial and all. So I prefer to use the thin plate spline, but you can play around with it and just check the mean error and all. But for this training, we'll just use the thin plate spline. So once you do this, you have to select your target SRS. That's more like your target CRS, like for coordinates reference system. So for this one, they are picking the WGS 84. Once you click on this drop down menu, you can click on which one you can click on. If you can't find, if after clicking on this drop down menu, you can't find the one you are looking for, you can always just go come here, then search for the one you are looking for. So for this, we'll be using WGS 84. So just click OK. Then compression, use LZW. Then we click. Make sure you check this load in QGIS when done. Make sure you do this. So you just click OK. Then you click on the Start Georeferencing. Then process all the off. So you can now close this. Probably save. You should always save your GCP points. You might need it for something else. So just save. Don't discard. Just save. It saves directly to your working folder. So this is our georeferenced map. If you come down here to see the coordinates, the CRS, that is the coordinate reference system, you can see that is WGS 84. If it was something else, maybe like UTM zone 31, that's for Nigeria, Lagos, it will show here and you will be able to see which one, which CRS you are using. So now this is a georeferenced map. So you can see if I just brought this in as an image, let me try and bring this in as an image. The one that does not have, that has invalid projection, that's the one that is not georeferenced. So I'll bring that in here. Clicking on layer, add layer. So it seems the raster file. Click on raster, then go to the folder. Change this. This. Close. So let me uncheck this. Can you see this question mark? Can you see what is written? Layer has no coordinate reference system set. This shows up when your reference, when your data does not have a coordinate reference system, and that means you need to georeference it. So if I click on this now, it will ask me to choose which one, but you can't just blindly choose the coordinate reference system you want to use. Sometimes you just have to georeference. So let's go to, if you go to source, that's for the one that is not georeferenced. You can see this invalid projection. These are ways to know when your data is georeferenced and when it's not georeferenced. So that's for that. So if I show you the one for the one we just the image you just georeferenced, if I do check the properties, as you can see, the source, this assigned coordinate is WGS 84. So this shows that this map has been georeferenced. So that's the first method of georeferencing your image, your data, your scanned PDF and all. So let's try the second method, which is using pin latitude. That's latitude, longitude. That's the one that you actually placed on the map using placeholders and all. So I have, so we'll go back. It's the same procedure. Just go to your raster, then georeferencer, then you bring in the data. Just open raster. So the second image you are using for this is the Aja. Then I'll click on open. So you can see that there's longitude, latitude on this one, and you can see the whole placeholders, the way I placed it. So for this, it's quite easy. All you just need to do is also zoom in, just zoom in. So make sure you zoom in very well. Then you had your points here. And zoom out so that you'll be able to see the tags. So your X is your longitude. Don't forget that your X is your longitude. So we have 3.60615 degrees. Then for the latitude, we have 6.446381. Click on OK. That's for the first point. Then for the second point, you just click again. So we have, for your longitude, we have 3.611581. Then latitude, we have 6.445946. So say okay. Then we pick another point again, the third point, which is this one. Just zoom in a little bit, then add your points. So we have your longitude. Longitude is 3.611615. Please make sure you cross-check your values before you start georeferencing, or make sure they correlate with what is written on the image. So for the latitude, we have 6.44556. So say okay. Then for the next one is the final point. Still click on your add point. And yes, you can delete a point. You can just click on cancel or come here, this delete points, move GCP and all. But since we are not doing that today, we already have our point on this map. We don't need to remove or anything. So just click on this and enter your longitude. So 3.607919. Then we have our latitude at 6.444278. So click on OK. Then the next thing to do is the transformation setting. So we are still using the template spline. So, and we are still using WGS 84. So, and our compression is still LZW. Then make sure you check this load in QGIS when done. If you don't, that means it won't load into the layers. It won't load as a layer in this your working project. You might have to just go back and bring the data in, but this saves you the stress. Just check this and it will load on the area you wanted to load. So after the transformation setting, you just click on start georeferencing. So as you can see, you already have this. So let's just close this and save. What's going on? Okay, please give me a couple of minutes. What's going on? Okay. I think there's a yeah.
Hello, Damla, can you hear me? Sorry, can you slow down a little bit so that the participants can follow? I think
Okay.
we are complaining too fast here.
Okay, I'll just do this the second method again so that we can see it. So we go to the raster to reference, then we bring in the data. So this is our data. Okay, I think there's something wrong with the data. Let's try the third method for now. I'll try and fix the issue. So the third one is using georeference data to georeference your scanned image or document. So come back here, then we'll go to the raster, then bring in the file. So we're using this Nigeria again because I downloaded the shapefile, the boundary shapefile of Nigeria. So for this one, we're going to use the boundary, that's the administrative boundary of Nigeria that is already georeferenced to georeference this image. So to do that, let's close this first and bring in the georeference data. So layer, it's a vector file, so we click on vector. So this is the grid 3 Nigeria file. Just click on this state administrative boundaries. This is the JSON file. Then open and add. So this is administrative boundary shapefile. This one is already georeferenced, as you can see the bottom. If you go to this down part of the interface, this EPSG, that's for WGS 1984. As you can see, that's current that's the CRS for this particular data. So we're going to use this georeferenced vector file to georeference our scanned document, which is this one. So I'm going to pick my first point. So to do this one, just pay attention to the points that you pick. So to do this one, I usually just follow state boundaries or just edges, follow the edges of the boundary itself, or maybe if it's a road network shapefile, you can follow maybe a line or something. So for this one, we'll just follow the edges of the boundary. So let's zoom in a little bit. and pick here this particular point. So first point should be here. Then instead of entering the X and Y, since we don't know the X and Y, or to just avoid confusion, let me remove this particular file that has the grid so that we don't get confused. Let me use this one, this image. This is much better. This one does not have grid, so we're going to use this one. So zoom in, then pick our first point, this part. So instead of entering the longitude and latitude for the ones that we did before, you have to click on pick points from your map canvas. So it takes you back to the georeference part. So you say from your map canvas, then you zoom in. You can zoom in, and but if you can see it, there's some superwomen that can see it. So just zoom in very well and pick your point. So from canvas, let's click on this. So it generates the longitude and latitude from the points that you picked. Then you click OK. Then you pick another point again. Let's pick the other side. Okay. I'm trying to pick sharp edges so that I'll be able to identify it on the vector file. Second point here. So we still say the same thing, pick from map canvas. So we zoom in, zoom out from here first, then move the file to this edge, which is similar to the edge we picked from. So we just go back here. So pick from canvas, then here. And do okay. So for the third point, do the same thing, zoom out a little bit, then look for another edge that you can use, zoom in a little bit. So that's another. So this is our third point. So pick from canvas. So zoom out. Pick here. Do okay. Then pick another point. Minimum of 4 points. Zoom. Maybe let's pick one here. Okay. I zoomed in too much. Okay. So pick points here. So pick from map canvas. And this is the point, this place. So okay. So that is our fourth point. So let's pick one more. Here. So still pick from the canvas. Can zoom out. Then move to this edge. Okay, so we're done with the picking of the points. So we can zoom out. So now we have 5 points. You can pick more points just to make it more accurate if you want to. So once you're done with this, you go to the transformation setting, then you have to state where you want to save the file. So I'm just going to say Nigeria boundary the file, then save. So as you can see, the format is changed. This once you are done with the georeference, it will change from JPEG to TIFF. That's the TIF. So you save this.
Hello,
Yeah.
Dami, can you hear me?
Yeah, I can hear you.
I think can you please redo the last process? I think a lot of people are following, and they are kind of lost. So maybe you can repeat the last step, please.
Okay. So let's do this again. So I'm going to delete all the points. Okay, so I'll use this delete points. Delete. Okay. So let's bring in our shapefile. The first one. This particular method is using a georeferenced data to georeference your scanned map. So for this particular method, I'm using a georeferenced boundary of Nigeria. This is the shapefile. It's a vector data. I downloaded it from Grid 3. One of the sources Oluwadamilola showed you where you can download your data from. So this is what I'm going to use to digitize another file, which is the scanned document. But for this one, I downloaded the image from Google Earth Engine, Google Earth Pro. So just click on your raster. From raster, pick your georeferencer. Then bring in the scanned document or the image. So locate where you saved it and bring it in. So this is the image you're using. This image one, and is a JPEG for is in JPEG format. So open this. So this is what the image looks like. As you can see, this particular image does not have grids, does not have latitude and longitude like the ones we did before. So this is just to show you that even when you don't have grids or latitude and longitude stated on the image or the scanned map, you can still georeference your data using another data that has been georeferenced, like all this vector data, maybe the boundary of your area of interest, the road network of the place. You can go as far as using a georeferenced building footprint or even point data, maybe like location of the country, the towns and the cities in Nigeria. You can use that if you have that kind of data that has been georeferenced already. So for this one, we're going to use that Nigeria data, this one here, to georeference this. So the first step when it comes to this is to pick your point. They call it GCP, that's the ground control points. They're picking it here. Then would just have to pick directly from the canvas instead of entering in the X and Y value. That is the longitude and latitude that we did for the first one. That's using the grid method. So to do this, you just have to pick random points on this scan document. But make sure that whatever point you pick, make sure you're able to identify that point on your canvas. So by doing that, just click on, let's pick our point now. So since I'm familiar with this Nigeria setting, I'm going to concentrate on sharp edges and try and locate that on the vector data. I'm going to zoom in and look at this is a sharp end. You can even follow the state boundaries. Let me zoom out for you guys to see. This gray lines are the state boundaries of Nigeria. This is reflecting on the map, the image itself. So you can use this. This just follow the state boundary. So you pick your point here, like this state boundary. Let's zoom in a bit. Okay, so can have our first point here. Then say pick from the canvas, pick from map canvas. Instead of entering the X and Y, this east and north, just pick from the map canvas. So can zoom in here. So this is the state that we used. Then just pick from canvas, and so it automatically generates the longitude and the latitude of the point based on the longitude and latitude generated from the georeference data. That's the state boundary. They're using that one to georeference this one. So the moment you click on a point on the georeference data, this enter map coordinate, there's an algorithm, something at the back end that generates this the latitude and longitude for you instantly, as you can see. So the latitude for this particular point is 10.9 and the longitude is 3.7 degrees. So once you do this, you click on OK. Then you pick 3 more points, or 4 or 5, but I like to pick 3, 4 minimum. So pick another, let's pick another point. So zoom in again. Zoom in too much. Okay, so we can use this state here. Okay, so pick points here. Okay, that's our second point. So you pick from map canvas. So this is the state here. This is the line. You look at it very well. See the shape. So sorry about that. So pick from map canvas. Then you make sure that you click on that edge. So it automatically generated this one. So that is a second point. So we pick another point. So zoom out again. It's just a game of zooming in and zooming out, just to find the right point. So this is another point here. So this is a top point. Then you pick from canvas. So zoom out. Then go to this down part. Then this is the point here. So click OK. Then the final point. Zoom out again. Then pick another point. So this is the final point here. Then we pick from canvas, zoom out. This is the edge. Okay, so now we have our 4 points. So we click OK. Then you can zoom out now to check on the 4 points. So we can see 1, 2, 3, 4. So these are the 4 points. So we have our 1, 2, 3, 4. You can have a point here in the middle, this Abuja, if you want to, but these 4 points are okay. So once we are done picking the points, then we can go to transformation settings. Then in the transformation type, you can use the linear, projective, polynomial, 1, 2, 3. But I prefer to use the thin plate spline because it has a lesser mean error. That's the average error. So you can find it at the bottom here. This transformation spline, the TPS mean error. You can find the mean error here. So I prefer to use this. Then you pick your target SRS. That's the coordinate system, reference system. So I'm using WGS for this one. Then you have to save the new file. So for this one, you just have to you can change the name. If you don't like the name QGIS generated for, you can change it, but make sure it's just a TIFF file. That's a TIF file. Then you save. Then you click on OK. Then you click on this start georeferencing, and once it is done georeferencing, it will load your map here for you, as you can see. So don't discard when you're closing your georeference app. Just save it, save your points. So just save GCP points, save. So it saves in working folder. You save it like this, then you can now see your image. And if you go to the down part of this interface, you can see this EPGS 4326. That's the coordinate reference system. And it is Word, that's WGS 84. So now that we've explored the methods of georeferencing, let's go into digitizing. So we're back to our presentation. So what is digitizing? So digitizing is the process of converting geographic data either from hard copy or a scanned image into vector data by tracing the features. So this is just basically talking about extracting data from your scanned image, your satellite image, then your pictures that you georeferenced or something. So this digitizing just looks into tracing the image, then having a digital version of that image. Maybe like on a particular map, we might have the map showing roads, towns, and rivers. Then we can have contour lines and all. But if you want to have a digital record of that, I can now trace the data, like having creating something called a shapefile. So, but the first stage of doing, you cannot digitize the data without georeferencing it. So for you to digitize the data, you have to georeference the data first. So after we've done the georeferencing. So we'll now extract information, maybe like the road network, or maybe the rivers, or the names of states in Nigeria. We can use that. And there are three types of, to do this extraction, we use the vector data type. And there are three major types of vector data. We have the line, the point, and the polygon. So when you're creating your shapefile, you have to tell the computer, okay, the shapefile that I'm creating is for a point data, or it's for a line data, or a polyline that they call it. It might show up as a polyline, then or a polygon data. So let me show you guys that how to create a shapefile. Then we can now maybe extract maybe maybe extract the states in Nigeria. So let's see that. So now that we have this image here, let's zoom in very well and see what we can trace out from this. Okay, we have um, some names that we can follow, but I don't think this map will be cool for digitizing. Let me bring in the first data with your reference. That's the Nigeria data, the one with the grids, so that we can see. So layer, add layer, it's a raster file, so just go to where that is. So open, then add layer. Okay, so I want to check this one. Can bring this to show. Okay. Okay. So this particular line, this particular map, if you zoom in, you can see um you can see settlements. You can see all this this dots that they are point data. So the names of maybe towns in Nigeria. We have this Ilorin, Ogbomoso, Oyo. Then we can see the rivers to these blue lines. These are the rivers. This is River Niger. This is River Niger here. Then River Benue. So from this map, we can look at, we can carry out our digitizing. We can do the 3D
Sorry guys. I think our network or something is wrong somewhere, but kindly give us some seconds while we rectify that. Okay, while we are waiting for her, can we get in questions? Um, can we get questions from the viewers so that we can start answering the questions while she comes back in? So the first question I'm saying is, do you have both the raster and the georeference data on the canvas together for this method? So yes, the data that is already georeferenced and the data you want to georeference, you have to have both of them on the canvas together for this method. So is it possible to show us how to georeference vector data in QGIS. So I'm trying to understand what you mean by georeferencing vector data because I think she's still going to cover digitization. So whenever you already have a vector data, most of the vector data are georeferenced. So if you have a vector data you added to the canvas and you see that it's not placed at the right place on the map, that is, it's not properly georeferenced, you have to check the CRS like she explained. So you have to check if the projection is correct. If the projection is not correct, you have to reproject. So there is also a tool to a vector data which is not appearing where it's supposed to be on the map. So all you have to do is reproject, not georeference. So um we want to follow with you, but you are fast. Okay. So the PowerPoint presentation will also be shared to us as usual. And if you have the QGIS software, you can still follow suit to practice the section. So just try as much as you can to follow up because like we rightly said, 2 hours is actually too small, but we try as much as we can to see what we can cover within that 2 hours. So please kindly bear with us. Um, for the data set she's using, we sent out the data set to everyone already via email. So you should be able to have the data set to practice what she's doing or watch the video again and follow through the practical. So how do you import the vector data um, on the screen? So if you want to import a vector data and you already have it, if you can see my screen on the browser panel, you have to locate where the vector data is. You add it to map, or you drag it and drop it on the layer panel, or you can go to um, the third tab. If you go to the third tab up, you see Open Data Source Manager. So when you open Data Source Manager, it pops up and shows you vector, raster, mesh, point cloud, CSV, which is delimited. So if you add vector data, you click on the data source, you see source. When you click on the source, it takes you to the data source. Then you add it to your map. So that is for someone who said, how do I import a vector like the state boundary? So when you download it, you can download it from G3 if it's Nigerian vector data you're looking for, like state boundary. For state boundary, you can download a full Nigerian shape file, which is a vector data. Then um, it has different segments in the data. You can select which state that you're looking for, or you can add all the states with the boundaries. Like we said sometime within the training yesterday, you can also use symbology to differentiate between states. So someone said, why is she not using CRS 31 North, which is Coordinate Reference System for Nigeria? So right now, Nigeria has, I think, 3 coordinate reference systems right now. So I usually use the middle belt. So the three of them are actually quite different, but the middle belt falls in place. So if you have any Nigerian coordinate reference system you are using and it works fine, it's fine. It's absolutely fine. Um, so another question here is, Dami, whenever you're set, kindly alert me. So someone is saying, um, battling with network. I've actually showed us how to get the vector map. It's two ways. You bring it from the browser.
I'm ready.
Okay. So continue. I was actually trying to answer some of the questions. So take over, please.
Okay, sorry about that. So back to digitizing. So now I brought in back my georeferenced map, and one way to find out if your map is if the georeferences, if you did it a good job georeferencing your raster data, you can bring in a vector file like the one I downloaded from Grid 3. That's the administrative boundary. This is it. This first one, and I shared this file. I think everybody has the file. So you can overlay the boundary on your georeferenced raster data. So as you can see, it's covering the entire Nigeria. There's no mistake or anything like that. But if your map, if this vector data is shifting from your raster file, that is, if this first one, this brown one, is not overlaying directly on your georeference data correctly, then that means you did something wrong. You might have to do the georeferencing again. So in order to avoid this issue, pick your points correctly. You don't want to have a map that is shifting away from the main, maybe the one you use to georeference it or something. So that is that about georeferencing. So we're going to I mentioned about digitizing and how we have three major vector datas. That is the point, the line, and the polygon. So to create a shapefile now, you just have to come here. This I think what is the name? You can come to browse. If you don't have this browse toolbox here, this um browse section on your interface, you can come here, just right click on anywhere on your canvas, then just right click here, then you can come here and pick the browse panel. So this is browse panel. So if you don't have it on your on your interface, just right click and check it here, browse panel. So once you do that, then you come down and you can do the whole vector file and everything. So you can navigate to this new shapefile layer, or you can come to this layer, add layer. If you already have the shapefile somewhere, you can do the add layer and bring it in. But if you are creating a new shapefile, just have to come here. You can do this add vector layer, or here. This is where you create a new shapefile. So you can either use this side or this side. This is the icon for new shapefile layer when you want to create a new shapefile. So I'm just going to click on this and this will pop up. So you're going to write the name of the file, whichever way you want it. So I want to pick the create a shapefile for a point shapefile to pick towns or cities in Nigeria. So I'm just going to type this as towns, then go to my file where I want to save it. Make sure that you go to your working folder. So save it here. Just save. Then you have to where this geometry type is where you pick if it's a point data, is it a point, is it a line data, or a polygon. So since we are picking towns, we are going to pick point. So if you want to add this field, is more like attributes. Attributes is like information about a data. That so we want to know the names of the town. So just write name. Then we'll put add to field list. Is it text? If it's the type, is it a text data like string, or is it a whole number, a decimal number? That's if you are doing, maybe you want to have a column showing the latitude and longitude of the points. But for this training, we just want to check out the names of the towns as we are entering, as we are picking our points. We want to attach an attribute that's an information about that point, and the information we need to enter is the name of the town. So we're just going to put text data, then we do add to field lists. Then make sure your CRS, that's your coordinate reference system, is still WGS 84 that we are using. If you are using UTM zone 31 or maybe zone 32 or anything, just make sure your CRS for the shapefile correlates with that of your raster data that we georeferenced. So you have your CRS must be consistent. You must have a similar CRS. Don't have for your raster, don't have WGS 84. Then eventually for your vector now have maybe projected mina 31 or something or UTM 31. It might give the map might not overlay very well. So make sure you have consistent CRS. So they are still using WGS 84. Then once you are done with this, you just click on OK. Then you can find to be added as a layer here. So now we're going to uncheck this just so that we can see the map under. So we zoom in this point. So we just pick. So to do that, you just have to enable editing here. This editing. So if you don't have the editing toolbar, you just have to right click again and click on editing, that digitizing toolbar. So if I uncheck it, it will disappear from my distance. So just check it, digitizing toolbar, you can see. So for those looking for the shapefile, if you can't find it, it's like if you can't find the shapefile icon, just go right click again and go to data source management toolbar. Then check it so that it will show there. Then click on the new shapefile layer so that you can have it. That's for those that don't already have the data management toolbar on their interface already. So now moving forward, so toggle edit. So once you click on this, this enables editing. Now you can edit this shapefile that we just created. Then we now have to start picking our points. So we have to do that by clicking on this add point features. So just click on it, then you can now pick. Make sure that you are picking directly. Go to the point and pick. Don't pick a point that don't pick the point that is outside whatever is on the map itself. So be careful when you are picking your point. Just pick a point, then check the name. According to the map, that point that we just picked, the name is Abeokuta. Can put ID, that's like a unique number, maybe 1, to show that that is the first one. Although the QGIS, when you open the attribute table, there will be a field that will be FD to show you the unique ID of each point that you pick, but you can still do ID as 1. So now we picked the first one, then you pick again, second one, Mushin, that's second, put Mushin, and pick again, Jebode, number 3. Just make sure that you are entering the name as it is stated on the map so that you don't eventually have this kind of mismatch of names with the point, and by the time you are doing your analysis or you finally designed your map and you're showing someone that knows about the area and you are putting Ibadan as Abeokuta, and the person start asking you questions like, when did Abeokuta become Ibadan? When did Ibadan become Abeokuta? So when you are picking your point, be sure of the places that you are picking and put their appropriate names. So we're picking the next one, which is Epe. So 3, or is it 4? 4. Epe. So you do that for the entire map. Pick randomly. So I'm just going to pick randomly so that we can have at least 10. So I'm going to pick here. this 5. And can pick here again, the 6. So that's for point data. And when you are done, you can just save. Just save it. Then we can now check the attributes. So we click on open. Once you right click on that layer like this, click on the layer, then right click, or just double click on the layer to show you this. Then this one. Or the best way is just to right click and go to open attribute table. So this is the attribute table. You can see this is the FD1, the unique numbers I was telling you about that QGIS will generate for you. And this is the ID that we gave the points ourselves. And we can see the names that we gave the points that we pick. So if I close this, after saving my data, I can stop. Once you are done editing, you can stop editing by clicking on that toggle editing icon. Then if you want to edit again, you click on it again, then you do whatever you want to do, then close back. So let's now remove the raster image and see the points that we picked. So we picked 6 points. So these are the 6 points. But if you do your map, if you just show this, you don't know the name of the point or anything. You just want if you want to display the names of the points, just go back, right click again on the layer, go to properties, then labels, then just click on this, click on single labels, then pick the value. See, assuming we had a column for latitude and you want to display latitude, just click on latitude. But since the only attribute that we have is the ID, which is 1, 2, 3, and if I click on that ID and I say apply, okay, you can see 1, 2, 3, 4, 5, 6. But this doesn't really make sense, so we can always go back, go to properties, then go to change from the ID. Once you click on labels, change from ID to names, then apply. Okay, you can see the names of the points now. You can change the color of the points too by clicking. You can change the names of the color. You can change the colors too by just coming to symbology. Then you pick color. You can change the color here. You just pick here, or just pick red. Then apply. Okay. So you can see. So that is for digitizing point data. So let's create another shapefile for line. So still come back here to the data source toolbox here and just okay. So let's create a shapefile for polygon. So I'll just say maybe boundary. That's for polygon. So I'm saving as boundary shapefile. Make sure you go to your document again, do boundary, then pick the geometry type polygon, then check the CRS. Then you can add the name of the boundary, maybe name 2. Make sure you check the type, then add to field list, then we do okay. Then the boundary shapefile shows, just check your raster data to show the image itself. Then you can now maybe do boundary of Nigeria. Can just do that by just clicking on the layer, then click the editing tool box, then you do add polygon feature. So just zoom in. Then just trace the map like this. Assuming we want to get the boundary of Nigeria, just pick it. Make sure you do a good one. Just trace it like this. Then as you can see, my polygon has started forming small. But just trace neatly, as you can see. So let's just say I want to do for this part only. Just I'm following this part. So just so you can say one and just give the name of the color, maybe West Africa or maybe Lagos. So that's how you create a polygon. See, it's different from the point. Let's overlay this. It's different from the point. Then you can do the same thing for the this thing. You can do the same thing for line digitizing. So you have to just create a new shapefile again for lines. Then say maybe rivers. You want to create a shapefile for rivers. Then save. Make sure you check your CRS. Then the geometry type this time will be line string. Then you can add maybe the name of the river by creating a new field or something. Maybe name again. Then add to field list. Then do OK. Then you can trace. Let me uncheck the boundary. You can trace the river. Let's see, maybe this small river here. You just have to click on the layer, then toggle editing, then you zoom in to see the river. This small, we just want to do this small one because there's no time. So just trace, go back to the editing tool, the digitizing toolbar, then click on this add line feature, then just go this way, this way, this way, trace it. So once you are done, just right click. You can put the name, maybe river, the ID will be one. Then maybe the name of the river is River Auction. Then just click save. Then you save it. That's how you do for all the rivers on the map, and that's how we create shapefile for the different vector data that we have. So now that we are done with digitizing, we can move to the creation of the map. So to design a map, we design maps in QGIS using the layout interface. So to get to the layout interface, just have to click on the project. From project, you have to just click on this new print layout. The moment you click on this new print layout, it will ask you to enter a name. So I'm just going to put maybe training map. That's the name I just want to give my layout, not the map itself, but the layout. So just put training map and click OK. It takes you to the print layout interface. So this is what the print layout interface looks like. And the tools that you need to create a map, everything is on this interface. So you just save first. That's if I saved my QGIS. But for you to save your layout, your print layout page, you have to save your entire QGIS project first. So let's just say training. I'm saving my entire work folder for this QGIS. I'm saying training. So this the file tab will be QGZ file. So just say save. So that way I'll be able to save my layout file. So just click save. So now that you have a clean layout view, to add your data or your map to this interface, now you just come down. All these toolbox that you've seen here, they all have their own role to play. So here, if you want to add your map, go down and pick add map. Just do this. Yes?
I think your screen is frozen. Yes, I think your screen is frozen.
It is?
Can you check?
How about now?
Rectify. Yes. It's just showing the Nigerian map.
Okay. Okay, share. I'll share it again. Okay, so can we see it now? So you can add your map by just clicking on this map add map icon here. Then just draw like a rectangle or a square or
Hello,
anything that
Dami,
you
sorry
like.
to cut you.
Just
Can you
draw
hear me?
this. Then your map show. Then you can now zoom in, zoom out, then do the whole can just adjust the scale here, maybe change this to 10 or increase it to 100 to show the entire map. Just keep continue increasing till you have your entire map. Then you can move the entire canvas with this
Hello,
arrow
Dami, can you
here.
hear me, please?
So just like move here, this one, move this the map that you had it, can move that. But if you want to move the item inside the map itself, you have to use this one, move item content. That's moving the map itself like this. So this is what this looks like. So if I want to bring in, so now that we added our map, you can add title of the map here. Just add label, can add label. Like just draw a triangle too, and just put. Can then in this item property, the other side, the right hand side of your interface, then just type the name, maybe Nigeria, font, maybe from like 10 to like maybe 40, 20. So you can see.
So I think we are lost at some point. We didn't see how you opened the print layout, the
Oh,
map creation part.
oh,
Maybe you can try to
let me do that again. So I'm going to close this. Okay. So I said to do to design a map in QGIS, we use the new print layout. So to get to the new print layout, that's layout interface, just go to this project, then click on new print layout. So once you click on that, it will ask you to enter a unique name for your printout layout.
Can you reshare your
Hello?
screen? We can't see your screen. Can you check and reshare?
Okay.
Just share your screen.
Yeah. Can you see it now? Can you see my screen now?
Yes, it's opening. It's loading.
Uh-huh.
Yes, we
Okay.
can see now.
Okay, so we just go to
Exactly from here.
the project, then click on new. Uh, okay, click on project, then pick and click on this new print layout. Then it will ask you to enter a unique name for your print layout. So you can just say maybe day 3. Then you click OK. Then it brings out the printout layer, the print layout for you like this. So this is a print layout. Everything you need to design a map is on this interface. Adding the map, adding the legend, adding everything to this one. So let's add the map first. So you just have to click on this icon, this add map icon on your left hand side of the rectangle is like this. So it shows your map like this. So you can increase or decrease the scale, maybe how you want your map to look like. As long as you can see, it's not covering the entire rectangle I created. So I can just maybe increase this to maybe 9. Or if as you can see, when I increase the number, the scale reduced, the image reduced. So we can just reduce since and see. So now that I increased to 59. So to move this rectangle shape, you just have to click on this select or move item. You can move around your square and everything like this. But to move what is inside um, the map itself, you have to use this order to just select item
Hello,
content.
Dami.
That way you can move the map like this or like this or anything like that. Sure. Then once you've adjusted your map to fill the entire area,
Hello, Dami. Can you hear me?
this then you can add click on add legend, then you draw the rectangle to come up like this. So it just auto populates your legend from your layout view, as you can see from the main QGIS, our layers. You can see towns, rivers, boundaries, states. So everything just shows up here for you. But if you don't want to have this partition, maybe you just want to show towns and rivers only, you can just remove this auto updates, then click on this and remove the three by clicking on this minus sign just to leave your town and rivers. Then you can edit the town. Maybe you don't want to just leave it as town. If you also want to maybe write Nigeria towns, you can edit it. Then
So that means I think immediately you start creating the map, we can't see anymore. I don't know where the problem is coming from. I can't see the print layout part where you create the map. So I don't know where the problem is coming from. Or maybe because of the screen you're sharing is a single screen. So whenever you
okay, okay. I'm so sorry about that. Let's see. Okay, what about now? Can you see it?
yes,
Hello, Nina.
yeah, now we can see the print layout path. So maybe just a quick yes, maybe just a quick recap from the layer. Show us where to come to this print layout place again. Then you create the map. I think
Okay, okay,
that would do.
okay. So just go to projects. From project, click on new print layouts. Then you add a name, maybe like the 2 or the 3, just add a name. Let's just use the 2. Put OK. Then once this layout view interface shows, you can now add your map with the icons on the left hand side of this list. So we have pan, then we have zoom and all. So we're just going to use this icon, this add map icon. Just click on it. Then draw a box, a rectangle or a square, just draw like this, then your map shows up. Then if you want your map to fit the entire canvas, you can increase or decrease the scale. For this one, you just decrease the scale, like 49. So it fits the entire area. Then you can now move the content of this move item content with this other icon. Just move it like this so that you can see your map can be centralized like this. So once you are done with this, you can add the main map elements like the legend, the scale, the not arrow grid and all like that. So let's add the legend first. So there's this icon here, add legend. So just once you click on it, you can now draw like a box here, and it's just auto updates everything, all the layers from this part, all these layers, the towns, everything, all this layer, it just shows up on as your legend here. But if you don't want to show, maybe you don't want to show boundaries, state administrative, all this, the last 3 layers, you can just uncheck this auto updates like this, then use this minus sign, this remove selected item, just and just leaves the entire legend. Then do this too. Then if you want to edit, maybe you no longer want it to just be towns, you want it to be Nigeria towns, just double click and put Nigeria, or whatever you want to put there. Then if you want to change this to, you can change it. Then you have this here. Then you can now put for the font and text formatting, you can have title, which is here like this. So can here in this title we have legend. That's it has changed here. So let's just move here so that we can see it. Then you can make the title bold. Just click on title font and just change this to bold. So now we have our legend. Then just place it on the map. Then you can add scale bar by clicking on add scale bar. Still, we are still using the icons on the left side. Just click on add scale bar, then just draw something like this. And there are different types of scale bar. Just can have the single box, double box, tick up and tick down. You can pick anyone, you can play around with it. So I'm just going to use tick ups, this one. So I'm just going to use this one. So we can see this 0, 100, and 200 kilometers. So the scale shows you maybe like the distance or the measurement of the reality to map values. Maybe if you're for example, now this one is showing us that maybe 1 centimeter on this map is equals to 100 kilometers in real life. That is what the scale bar shows you. So I mentioned that in the PDF, the presentation, when I was talking about okay, see, for interpreting land area distance. Then I gave examples. Then we can add the next map element, which is the north arrow. Just click on add north arrow. Just draw a box too, and it shows up like this. But make sure it is attached to a map. So if you come here and we check this, you can see this part where it says cite with map. If you don't cite this with the map, when you want to export this image, it will tell you that maybe let me uncheck first. Let me uncite this one, uncheck this one, and try to export the map as image. See this, I'll just click on this export as image here. See this error will come out that not arrow is not linked to a map. You must make sure that it's linked to a particular map. That's the map that you're working with. So just click on cite with map so that you can export your not arrow with the map itself. So now we have the 3 elements already. So the next element to add is the title of the map. So just click on add label, then draw a box to like this. Then in the title, this your right hand side, you can see this main property. Then this lower this thing. You can change it to Nigeria map. Then you can change the font to maybe like 20 or something, 18. Then you can make it bold and just do okay. So now here we have our title. Then you can now make it centralized by putting maybe just this horizontal alignment, just put center. So now we have our title, just have to move it a little bit. So here is our title. Just adjust this a little. Okay, so now we have so the next thing to add is our grids. Just click on the map itself, this one, then just go down the right hand side, you see grids. Just check the drop down menu, then click on add a new grid, then modify grid. So here you can now put maybe your X and Y. Since Nigeria is when we're doing the latitude longitude georeferencing and all, we saw 4 degrees, 8 degrees and all. So we can just start with maybe 1 degree. The moment you enter one, you start seeing this. As you can see, the lines have started showing. So let me take it back for you guys. So let me change this to 0. Let me change this to 0. And you don't have anything there. So the moment you pull 1, and you pull 1 here too, the grid line starts showing. Then you can now show if it's you want to blend it. Do you want it light? Do you want it darken like this? You can play around with it. Then you can now draw the coordinate, like I said, so that someone else can use this map in the future. When you once you place your grid on your map, show the coordinates of the grids, show the labels. So just click on this draw coordinates. You can change from decimal to maybe decimal, degree, decimal, minutes. You can use degree, minute, and seconds. So let's just use degree, minute, and seconds. As you can see, you have all this 11 degree east, and we have 13 degree north and all. So you can then do this, arrange it so that this does not just extend outside of the map. Then you can do the same thing for this one. You can put it inside the frame like this, and you can take it outside. Then you can do the alignment as horizontal, descending, or something, just to fit into the map canvas itself. So once you are done with this, but now if you look at this map now, the grids, they're not really looking nice. So I'm just going to adjust it a little bit. Just changing that one to maybe 5 or 2. Maybe just play around with it, right? Right. And see the lines have changed. So now we just have 3 at the top, 2 at the sides, and 3 at the bottom. This looks better than the old one. So once you are done with designing your map like this, you can now export or do so once you're done, this is like the final output of the map. Then just do export as image. You can export as image, you can export as PDF, then you can export as SVG. So let me just export this as image. So just go to your working folder. You can change the format from JPEG, you can do PNG, you can do TIFF format and all. So we just pick it here, JPG, then save. So then you can adjust resolution and all, but I prefer to leave it 300 like this, then you just put save. So if you go to this folder by clicking on this link now, to take you to where the data is, the image is saved, then you click on it and check it out. So let's see the end result. So this is what the final product looks like. So that is how you design a map. You can add a rectangle, like a neat line around this entire map by clicking on this add shape. Add shape, just click on rectangle, then just cover everything up like this. Check it. Then once you do this, then you can come down to this this style, and just change the color and all like that. Well, it's not necessary, sure. This is just to show you how things are done. So this is how you design a map in QGIS. So if you guys have any questions for me, please start talking about it.
I think they are trying to follow up now after the screen was freezing. So and we are just 8 o'clock on the dot now. So I think we can end the session now. Most of them, when they drop a question via email and comment section, we can try to um, answer their questions, and we would also send them the material that you have used for today. They already have the data sets. We'll send the PowerPoint presentation you used initially to them after this presentation. So maybe we'll have to call it a day now. Thank you very much, Oluwadamilola. That was a very interesting section. And we'd also want to extend our greetings to our viewers. Thanks for your patience. So we'll see you guys tomorrow for the next section. Don't forget to subscribe to our YouTube channel so that you would get updated once we start the section for tomorrow. Also, try to get the QGIS set up. And if you have any challenge with the QGIS, I see some people still have some challenges. Kindly reach out to us. We'll make our time to answer your questions. So, thank you very much once again. We'll see you tomorrow, guys. Bye. Cheers.